section 2. Okay, starting in section 2, I started labeling the title, because I had some people ask me the order, and they're kind of confused about the order of my notes. So I'm going to try to do better. So starting in starting on section 2, I put the number at the top, but I didn't on this one, so I want you to add it in. I want you to write. This comes from 4.1, so if you ever need to reference the textbook or go back and find where some of the stuff comes from, we're starting chapter 4 today, section 4.1. Okay, we're looking at quadratic functions, and all quadratic functions terms, right? They're x squared functions. So everything that we do now is going to have x squared. The last bit we did was like absolute value, right? We did linear, we did line. So now we're looking at quadratic functions, which are x squared terms. We're going to start with everything being in what we call vertex form. Okay, so everything that we're going to start with today, this first sheet. So we're going to go through our notes. I'm going to give you about 20 minutes to practice, and then we're going to come back the last 15 minutes, and we're going to start the second form. Hopefully we can get through it. Okay, the last thing I want you to add to the title, what is the shape of all of these graphs? U. So I'm going to go ahead and note that. If we're asked to graph an x squared term, it's got to be what shape? It's got to be a U. So absolute value is going to be a v. Y equals mx plus v, right? It's just an x, it's going to be a line. Now we have x squareds. These are going to look like u's. Middle. And we're going to start by graphing our parent function and talking about all of the characteristics and basic properties of these. So the parent function is what we said, y equals x squared. So we did the t-chart on how we got these points in our warm-up. Graph what the basic parent function looks like. The first point was 0, 0, right? We said if we take 0 squared, so what happens if we square 1? We get 1. So the next point is 1. 2, we got 4. So we get 2, 4. Right, if we were to do the next one, it would be the 0.39, right? But this isn't put on my graph. Negative 1 squared is also 1, and negative 2 squared is also 4. I notice that it kind of looks like a V. Big slope, right? These lines don't have slope, they have a little bit of a curve to it. So we're going to connect them, we call it a parabola. Make sure that you round the edges just a little bit so they know they're not perfectly straight lines. All right, so all the graphs in chapter 4 are going to be some variation of this parent function. I would memorize like these 4 or 5 points. Negative 1, 1, 2, 4. You can just learn 4 or 5 points. Everything else is going to be some variation of those points. Right? What do you notice about both sides of this parabola? What happens if you fold it in half? We call that property symmetrical. So just like absolute values, okay, these parabolas have what we call an axis of symmetry. Okay, the axis of symmetry is at x equals 0. They also have a vertex. What's the vertex of this parabola? 0, 0. Thing that we're going to add, and the thing that's a little bit different, the little, like, you know, there's sometimes like some sub questions. The thing that parabolas are going to ask, does this have a minimum or a maximum value? Okay, here's how you answer that. Is it the highest or the lowest point on my graph? The lowest, so we have a what? Minimum. So I'm going to draw an arrow to the vertex. We have a minimum of 0. Y'all see how 0 is the lowest possible and everything else is getting bigger than 0. Right, so there's a minimum of 0. What do you think would have to look like if it had a maximum? have to go down. All right, so we'll get to one of those, but it goes down. Are we okay so far? So there's two more little things here, and then we're going to kind of talk about all of our transformations. The first one is domain. Domain represents all of our x values. These arrows tell me left forever and right forever. And if it goes left forever and right forever, you see that's going to cross the whole entire x-axis eventually? It's going to be all real numbers. Okay, just like absolute value, the domain of quadratics is going to be all real numbers. The last little piece here, the range. How do we get the range? Range represents what? If domain is all the x values, range are all the y values. So let's flip it over. We've got y at 0. So I want you all to look at your graph. Are we graphing everything above 0 or below? Above. So what inequality are we going to use? Equal to. Parent function is y greater than or equal to 0. Now, how do you feel about that? You can just get this little bit right here, then you'll be okay, because everything else about this chapter is stuff chapter 2. All right, so from here, we're going to go to the bottom left box. We ready? And this is going to look very familiar to you. So this is vertex form. There are two forms. So we're going to do vertex form first, and then we're going to start talking about standard form near the end of today. So this is vertex form. Just like before, sometimes there's a negative, right? Not always, but sometimes. We then have an A, parentheses. Okay, A, parentheses, x minus h. Y'all see this looks very familiar? It's just like absolute value, but instead of absolute value, we have a squared, right? Because my function is squared. What do you think goes on the outside? Okay. So it is the exact same formula we used for absolute value, but instead of absolute value, we have a squared because we're dealing with quadratics, right? Everything is squared. Let's kind of review a little bit. If you ever have a negative out in front, what's that going to do? If we have a negative. What's the word we use? It is going to make it up and down, but what's the word we use? Flip's fine. Reflect. Okay, flip or reflect. I'm going to write reflect, but flip is fine. If there's ever a negative, it's going to reflect. And we then have to talk about the h. And the h is on the inside, so it's going to go which direction? Up and down or left and right? It goes opposite. Left or right, depending on what's in there. Okay, it just depends. So I'm going to say h is going to move left or right. I'm going to be the opposite of what you think it should be. So all that's still the same. If h goes left or right, then k is going to go up or down. Which leaves the last thing, which is the a. So what is the word that describes what the a is going to do? The a is going to do what? Stretch or compress. Okay, so a is going to stretch, compress. We've got to add a little bit to this because what was the a? What did the a do to the line? What was a? Y'all know this. Absolute value. The a represents the what? Slope. Okay, but if we don't have straight lines anymore, can we have slope? No. So a is not the slope because we don't have lines. Y'all good there? What I'm going to say, it's going to move the 1, 1 point. The 1, 1 point is in just a second. It's kind of like slope, but only for 1 point. And after that, you can't use it like slope. Otherwise, you have these. We can't have these. We've got to have this parabola. We've got to have this curve. What I want you to write is if you go 1 away from the vertex, is what that means. You're going to go to A. Those things mean in just a second. But we can no longer say that A is slope because we don't have straight lines anymore. And the two things we're going to say about A. First thing, it's going to move to 1, 1 point. Second thing, 1 away goes to A. We can use that if it's not a fraction. If it's a fraction, it's kind of more complicated. That's going to be our shortcut. Okay, so if we know all of this, what do we think the vertex is? Still H and K. Right, just like absolute values, the vertex of H and K. Axis of symmetry is always equals H. Okay, the domain is always what? Numbers. Okay, so none of this has changed. So the domain is always all real numbers, and the last little piece for the range, it's either less than, greater than, or equal to. Opens up. We'll use greater than or equal to. If it opens down, if it opens down, then we're going to look at less than or equal to. Feel so far. Okay. So we have 3 that we're going to do. And once we get through these 3 examples, I'm going to give you some time to practice. So we're going to start in the top right corner. Okay. And I'm actually going to change this problem because fractions are where people were all messing up. So I want you to make this 2 into a 1/2 and turn it into a 1/2. Because when I kept it as a 2, they were fine, and then on their math Excel, they got a fraction and like nobody knew what to do. We're going to turn this into a 1/2. Before we go, I want y'all to point to this -1. That -1 is going to do, or how it's going to move my function. I hear right 1. Anyone agree, disagree? Okay, inside does the opposite, and it is going to move left to right, so I'm going to write that. It's going to go 1. Bless you. +3, bless you. What is the +3 on the outside going to do? First thing I want you to do is go right 1, up 3. Okay, another thing that you could say is that the vertex is the point 3, 1, which we just graphed. Okay, so I'm going to take, actually, I think Raven might have borrowed my pencil, so I'm going to use this gray line. Y'all don't have to write this. But here's what we're going to pretend right now. Yes? Did I do it backwards? Darn it. But I did it right. I just wrote this backwards. Is the graph right? Okay, yes, thank you. That means anyone at home watching. Okay, 1, 3. So mentally, you don't have to draw this, but mentally, here's what we're going to pretend. We move the vertex normally at 0, 0. So we're going to pretend that the vertex is like 0, 0. All right, okay there? It's like we're changing the center of my graph to the vertex. And right, to graph the point 1, 1, around the vertex, you would start there and go over 1, up 1. So we're going to pretend that the vertex is my new, new x and y axis. And we can almost graph this, but we have this 1/2. Chart for a couple of points so we can talk about the 1/2. Now, what do we do if there's a fraction? fraction, it's probably helpful to make a T-chart, but I want you to write something. Sorry, for just a second. If there's a fraction, instead of choosing 0, 1, and -1, choose multiples of the denominator. Because if you choose 1, -1, and 0, you're going to get fractions. And we don't want to drag fractions. The denominator of your fraction is what you're going to choose. So if you don't have a fraction, you can choose 1 and -1, right? So there's a 10, 1, -1. We're going to choose multiples of the denominator. What's our denominator? 2. So instead of plugging in 1 and -1, 2, 0, and -2. So we have 1/2 of 2 squared. So what's 2 times 2? 2 or 4/2? 2. So I get a 0.22. And then I'm going to plug in 0. 1/2 of 0 squared and 1/2 of -2 squared is again 1/2 of 4, which is just 2. And we're going to take these and we're going to plot them. Okay, but we are going to plot these points the vertex. I'll plot these in. We're going to actually plot the point 2, 2. Now recognize that? We're going to go to the vertex. So I want you to hover your pencil over the vertex. I want you to plot 2, 2, but the vertex is your center. Where are you going to end up? You're going to go right 2, up 2, and put it up. Y'all see that? How we're moving from the vertex. And so I'm going to show it again. From the vertex, I'm going to go right 2 and up 2. 0, 0 is just the vertex. And then I'm going to go left 2 and up 2. Okay, once I get those, I know it's going to look like a U. So I can just finish it. Okay, how do we feel about that? Can we do that? Yes, huh? Okay, the other thing I told you is 1 away, go to A. A was 1/2. If you look one space away, you see how the graph is somewhere in between 0 and 1. Another example of how A is going to give you like your 1, 1 point. 1 away, go to A. All right, yes, no. Can we do that again? Graph, then we're going to do an analysis problem. And then we're going to go from there. Before I go on to the next one, y'all have any questions? Or do I need to re-say something we didn't quite get? All right, so the next one we're going to do is the left corner. Okay, so we're going to go to the left corner. We're going to graph this next one. All right, so this time it's asking us to find the vertex, axis of symmetry, domain. Let's start with the vertex. Y'all should be able to tell me this by now. What's the vertex? Yeah, I see a 3, -1. Inside, we're always going to use the opposite. So we have a -3. So what's the first point we're going to plot? -3, -1. The thing we need is the axis of symmetry. So I'm going to put x equals because it's always x equals. Goes to the vertex, what's the x value of that vertex? -3. So it's x equals -3. So I'm going to draw a dotted line that goes through that point. All right, so let's talk a little bit about this. And I'll go up this way. Let's talk about what's happening. So I'm going to come and I'm going to draw an arrow first to this negative. And what is that negative doing to my parent function? Saying it's flipping or it's reflecting it. So I'm going to go ahead and note that. It's reflecting. What did the +3 do? It went to the, and then -1 moved it down. Okay. And if I could do this, I would. Parent function that we started with. It's like if I was on the computer, I could like take a picture of it. The first thing I'm going to do is I'm going to reflect it. So all those points that are positive are now going to be negative. I'm then going to shift that picture to the left and down. So if this U, we flip it down. We're then going to go to the left and we're going to move it down, and that's where we leave it. After that, so we already moved it to the left and moved it down. We haven't done yet. We haven't flipped it or reflected it. So let's look right here. On the original, if you can just learn this point, you see how we have the point 1, 1? What is that point going to become if I reflect it? 1. So I'm going to go over 1. The second point is 2, 4. If I reflect 2, 4 from the vertex, I'm going to go 2, 1, 2, 3, and down 4. We can connect them. Okay, it's the same exact U. We reflected it, we picked it left, we dropped it right down, and then we left it there. Okay, same point, reflected, left, down. Y'all visually see it or we don't see it? And the other thing that I told you, 1 away gives you A. So I want you to look. 1 point away from the vertex, we went down 1 space. Right, 1 away gives you A, so if you go 1 away from the vertex space, and that's where you stop. You can just get 1 or 2, 3 points. You know the rest of it, so the rest you can just kind of guesstimate. It doesn't have to be perfect. As long as you're like, if they're okay, then I'll give you credit for it. As long as you can get that little bit. And how do you feel about that? Now tell me this, does this have a minimum or a maximum? Arrow to it. We're going to write max. What is the maximum value? What's the highest this graph can get? -1. Okay, so I showed you one that had a minimum. If it opens up, try it as a minimum. If it opens down, it's going to have a maximum. So we're almost done for a little while. We've got one more little spot. This one we're going to go backwards. So the last one we're going to do, I'm giving you the picture. Write the equation. All right, so here's the last one. Questions before we go on to the last one. All right. So here we are. Bottom right. Given the graph, write the equation in vertex form. You're right. Anytime we're going to write in vertex form, we need 3 things. 3 things we have to fill in. The vertex, what letters do we use to describe vertex? H and K, we need one more thing. What do you think of this? A. So we need A, we need H. Okay, once we get A, H, and K, it's just a matter of plugging into our formula. Give you a picture or whether they give you the points, 2 of those things. And what 2 things can we find really simply? Given this picture, what can we find first? The vertex. I want you to draw an arrow to the vertex. write what that point is. What does it look like? -2, 2. I'm going to write that this is my h and my k. The first thing that we did is we h and k. Okay, for this problem, what is h? And k is +2. We have 2 of the 3 pieces. The second thing I'm going to look at is I'm going to go one space away from the vertex and see if I get a whole number. Y'all see how there's a fraction? It doesn't go perfectly through a line. If it goes perfectly through a line, we're done. 1 away gives you a. So 1 away, you're up 2 spaces, a is 2. 4 spaces, a is 4, -4. Okay, but since we have a fraction, we're going to have to algebraically find a. Okay, so here's the second phase of this. Okay, we're going to use the vertex and a point to find a. So we have the vertex. We need any other point. Find a. Do we have another point on this parabola? Point. Yeah, they actually give us more than one. But I went ahead and highlighted this one because what's the x value of that point right there? It's going to be easy to work with. So now I'm going to draw an arrow to the point that they give us. Okay, that point is 0, 3. And under that, I want you to write x and y. H and k, I have an x and I have a y. Y'all agree with that? And here's how we're going to do this. I'm going to write vertex form. Parentheses, x minus h squared plus k. And anything that we know. Now, when we do this, what's the only thing that we shouldn't have filled in? What's the only thing we're trying to find? A. So we should have everything filled in except for A. So I'm going to start with y. Do we have something over here that we called y? 3 equals. I don't know A, so I'm going to leave A. Do we have something that we called x? Okay, do we have something that we called h? Negative, so I'm going to have -2 squared. Okay, do we have something that we called k? We now have all numbers in one variable. Okay, the variable that we don't have is a, so we can now solve for a. All right, so here's what it looks like. A equals A. What does that -2 become? +2. What is 0 plus 2? 2. We have A times 2 to the second power plus 2. 2 to the second power. So here's what we're looking at. 3 equals 4A plus 2. Is this something y'all can solve? Get pieces in the right place. I'm going to subtract 2. So 1 equals 4A. 4, what does that make A equal to? 1, 4. I know, that's why I was using the other kind. I heard that. I started using the other kind and then I forget, okay? I know, they look like 9s, but there are no 9s in this problem at least. I will underline all the things that I just found that we need. We needed K, we needed A. Y'all see that? My final answer, I'm going to take those 3 pieces, I'm going to plug them back into vertex form, and I'm done. So here's what my answer looks like. Y equals And I'll put it here. I'm going to put this in and this in. So I have y equals 1/4. Right, instead of a, we're plugging in 1/4. The double negative is going to make HA positive squared VA plus 2. Okay, and then I'm done. I will do all that. Okay. All right, so I have to assign. Okay, so this time I did remember. So go to the top. We are now looking at standard form. Okay, standard form. So all the important stuff is going to be in the middle block. I want you to put a box standard form. Here's what standard form looks like. Okay, ax squared plus bx plus c. Okay, in grading these tests and stuff over the past few years, I want you to make a note of this because people miss this. It's going to be alphabetical, A and B and C. How do you find what A is? It's always with what? Looking at it. It's not alphabetical, A, B, and C. A is always whatever's with. Okay, B is always what's with the X left over. I'll try to trick you on these and I'll put them in a different order. So I need you to start to train your brain. A is with X squared. Right? B is with X, whatever's left over. Okay, unfortunately, this form does not give you the vertex. But in order to graph, you have to know the vertex. Symmetry, which is the x coordinate of the vertex, we're going to use a formula to find it. One you've got to memorize because this is not on the ACT formula sheet. So I'm not going to give it to you. To find the axis of symmetry, x equals negative b over 2a. The axis of symmetry is also of the vertex. We call h. So to find h, the formula that we're going to use is negative b to a. If you're a highlight person, you need to highlight that formula. I'm not going to give it to you. Huh? Okay, I missed you. Oh, where did I put them? I didn't put them back there. The second thing that you've got to know. You're going to plug in h to get k. Okay, because in order to graph these, we're going to, and eventually, right, we're not going to graph them today. Eventually we will. In order to graph them, we need the vertex. So to find h is a little simple formula, right? Negative b over 2a. Okay, we're going to plug h into the equation, and then we're going to get an answer. So it's just algebra and calculator stuff. Okay, how did we find y-intercepts back in chapter 1 when we did line? Do y'all remember? What did we do with x to find the y-intercept? Not intercepts. If we're doing y equals mx plus b form, we might do that. But just generally speaking, now what did we do with the x when we wanted to find the intercept? Y'all remember this? We just did this. How do we find it? What did we turn x into if we wanted to find the y-intercept? Y'all know this. Somebody knows this. I know. I'll wait. I'll let y'all think. How do you find intercept? Y'all know this. Somebody knows this. Y'all just tested it, and I know you got it right. Somebody tell me. What do you do with x if you want to find the y-intercept? You cover it. Thank you. You turn it into 0. Cover this x, and you cover x. What are you left with? If x squared goes away and x goes away, what are you left with? Intercept is the point 0, c. Okay, this next little piece does also apply to vertex form. Now put your phone away. Okay, but I want to give it to you formally. Is positive. Is the graph going to open up or open down? Y'all tell me that. Up. So I want you to draw that. I don't know, just because I don't ever think about it. Okay, if A is positive, do we have a maximum or a minimum? Okay, there is a minimum at K. So what happens if A becomes negative? What's going to happen to that U? It's going to flip. A minimum, we're going to have a maximum. The top. What I'm asking you to do is find the vertex algebraically. So this is what I want you to do. I want you to identify A, B, and C. Okay, Evan, I want you to wait to finish that because this is a whole other section and you're going to miss it. Okay, so I'll tell you where it's at. Identify A, B, and C. So looking at this, can y'all tell me, what is A? What do we think A is? I'm just going to put the 2. We just care about the numbers, but you're right, it's with the x squared. So A is just the number 2. What is B? 6, what kind is this? Negative. So B is -6 and C is 3. Okay, that's half the battle, is just getting the pieces to the right place. The thing we're going to do is find H. And the way we find H, we just plug into our formula. Over 2x. And negative B over 2x. So I'm going to show this step, even though I know some of y'all could probably do this in your head. -6 over 2 times 2. And that double negative is going to become a. So we have 6 divided by 4, which is 1.5. And that leads us to the last step. Once we find H, we're going to plug in H. And it's going to give us K. So we're going to take that equation, X, with 1.5. Here's what it looks like. Parentheses, 1.5 squared. So instead of X, we're going to plug in 1.5. 6 times 1.5 plus 3. Okay, I know it sounds silly, but I want you to get your calculators out and make sure your answer matches my answer. Because what a lot of y'all will do is you'll take 2 times 1.5 and say that that's 3. Is that correct? What comes first, multiplication or exponent? Exponent. So you got to take 1.5 squared first by 2. So that makes sense. So I want y'all to get it out and try it. And make sure your answer matches my answer. Try. Okay, the question is, can you just type it all in one piece and hit enter? Some calculators you can and some you can't. So try it. But if you don't, then you've got to go through step by step. Okay, so when I plug in 1.5 squared times 2, I get 4.5. So make sure you get that, 4.5. And minus 9 plus 3, final negative 1.5. Okay, and y'all can trust me on it, but I want you to try it. If you can type it all in one piece and then hit enter and you get negative 1.5, middle step. But if you can't, then you're going to have to show that middle step to make sure that you can get there. Okay, so I want you to try it. How do I write my final answer? Right at the point, h comma k. What we're going to do is we're going to write 5 negative 1.5. Okay, h comma k, 1.5 negative 1.5. Yeah. All right, how do we feel about that? We okay? Okay, we got one more, and then, how annoying. Yes, 1.5 comma negative 1.5. We have one more. You have 15 minutes. And really, if you're on your phone the whole time I'm talking, I'm not going to let you go. I didn't ask you if you were now. All right, here's the last one. Transformations. Okay, when we identify the transformations, we need things to be in vertex form. So even though that was on the last one, I'm going to remind you. Vertex form. In the big arrow, I'm going to put vertex form. Okay, vertex form was y equals a times x minus h squared plus k. Things into vertex form, we can talk about deflect, stretch, compress, move right, move left. Okay, but until we get into vertex form, we can't do that. Standard form, we're going to write in vertex form. In order to write in vertex form, we just have to find the same process, but we're now going to answer a different question, but we're still going to do the same thing. Okay, so I want you to write down what you think A is, what you think B is, and what you think C is. They tell me A, B, and C of this second problem. So what do we think? What is A? Negative 6. What is B? Negative 12. What is C? Okay. Then we're going to find H by using negative B over 2A. So y'all tell me what H is. Negative B over 2A. And see if you can tell me what H is. Y'all get it yet? Anyone? What'd you get? And I got negative 1. We agree, disagree. And the top, the double negative becomes positive 12. The bottom gives us negative 12. And 12 divided by negative 12 gives us negative 1. We follow? Okay, how do we find K then? We plug in negative 1. So I'm going to give you a chance to try it out. We have negative 6 times negative 1 squared minus 12 times negative 1. Again, some calculators, you can just type that in and hit enter, and it will give you the answer. Some of you actually have to like do it step by step. If we look at this, 1 squared, negative 1 squared is going to give us a positive 1 times negative 6, negative 6. And negative 12 times negative 1 is a 12. Minus 1 altogether, that gives us not negative 5, 5. All right, so I'm going to double underline. To write in vertex form, we need H A and we need A. Tell me if we have enough pieces. Okay, tell me one thing that you know that we need to plug in. Right here, A. What is A? -6. A in standard form is the same A in vertex form. Now, don't we know H and don't we know K? So now we're going to rewrite, but I'm going to plug in what we know about A, H, and K. So we're left with Y equals -6. X minus -1 becomes a positive plus 5. 3 words away from being completely done. Now here's vertex form. Attention to what is the question asking? Yeah, identify the transformations. So once we get vertex form, it's just a matter of drawing our arrows. Y'all see we have a negative. What does the negative do? What word do we add? All we got to do is add the buzzwords. Flip. What does the 6 do? Stretch. Stretch or compress, and since it's bigger than 1, it's going to be a stretch. We have the +1 on the inside, which is going to make it go to the last thing. We have a +5 on the outside, which is going to make it go up 5. The green answer. Right, but we had to take standard form and put it in vertex form so we could then talk about the negative, the A, the H, and the K. It's transforming.